Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn how to identify the equation of a cone. Okay, before we start, I'll remind you a story from class 9 or class 10 or maybe class 11 that you learned in pair of lines. Okay, one of the most beautiful results that you learned in pair of lines is given any pair of line or the combined equation of a pair of line will be the general second degree equation in two variables. That is, given any pair of line, or if you combine two lines into a single equation, your equation is supposed to look something like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So this is what you learned long back. And then you learned that it is an implied condition, not an if and only if condition. That means it is not a reversible condition. That means if you are given a general second degree equation, general second degree equation means all the second degree terms, the first degree terms, etc., 0th degree term will be there. Okay, but given a second degree equation, general second degree equation, it need not represent a line. It can be lines, it can be circle, it can be parabola, ellipse, hyperbola, etc., etc. So this is what you learned long back. And immediately after that, you learned how to recognize. I think you might have learned the determinant method. Or maybe if you learned this in class 10, you might have learned like ABC minus 2FGH, etc., etc. You might remember. And you know very well that what you call pair of lines is connected to the what you call the three-dimensional counterpart, the cone or the double cone. Okay, similarly, in 3 dimension, what I am going to teach you now is the general second degree equation. The general second degree equation, that means it will have all the square terms. And now let's use FGH. Okay, f into xy plus g into yz plus h into zx. Then it will contain first degree terms lx plus my plus nz plus a constant equal to 0. So look at this. The equation of a cone will always be a second degree equation in 3 variables. But a general second degree equation in 3 variables need not represent a cone. It can be a conicoid. I told you what is a conicoid yesterday. A conicoid means ellipsoid, paraboloid, hyperboloid, etc. Or it can be a sphere, or it can be even a cone. So got it? So today we are going to learn how to identify whether an equation represents a cone or not. Okay, let me remind you one more beautiful result that you learned long back. Look at this. If you have two lines passing through the origin, that means if you have a pair of lines passing through the origin, then its equation will be a second degree homogeneous equation. By the way, the word homogeneous means same degree. And this is an if and only if relation, double implies. So, if you have a pair of lines passing through the origin, the equation will be homogeneous second degree. And if you have a homogeneous second degree equation, there is only one possibility, that is, it should represent pair of lines through the origin. Okay, let me make it very clear once more. Long back, we learned about 2 different equations. The general second degree equation and the homogeneous second degree equation. General second degree equation can represent any of the conics or pair of lines. But homogeneous second degree equation always represents a pair of lines passing through the origin. Similarly, a general second degree equation in 3 variables can be a conicoid or a cone or a sphere, etc., etc. But a homogeneous second degree equation in 3 variables will always represent a cone with the vertex origin. Okay, now let's come to the problem. Okay, now there is a determinant condition, but it's a 4th order determinant, like what you call it will be so difficult for you to handle. So I'll give you one easier technique actually. We use slide maxima, minima techniques, etc., etc. Okay, so look at this. They have given you, is it homogeneous or general? General, because look at this, degree 2, degree 2, degree 2, degree 2, degree 2, so same degree. But now look, degree 1, degree 1, degree 1, 0 degree. So this is a general second degree equation. So it can be a cone, it can be a sphere, it can be ellipsoid, paraboloid, hyperboloid. Generally speaking, it can be a conicoid. Okay, so this can be a conicoid or a cone. Now they are asking you to prove that it represents a cone. So I'm not going to give you the determinant method. You can check any standard book. You will see one determinant condition, or you can search online about it. The easier method is, what we do is we are going to homogenize it. Do you know what happens when you homogenize? When you homogenize, it will become a guaranteed cone. And then we will find the stationary point of that cone, and we will prove that, like what you call, there is a stationary point. And there is only one stationary point. And hence we are so sure that it is a cone. And if the homogenized equation is a cone, then this is also a cone. Okay, we'll come to it. So what we do is we are going to write like this. In exam also you have to write the dialogue. Homogenizing the given equation using the variable t, which has a value 1. So what is the value of t? Yeah. Homogenizing the given equation with the variable t, which has a value equal to 1. So what I did is a very small trick. Look, degree 2, degree 2, degree 2, degree 2, degree 2, because product of variables will have sum as the power. So the degree will be the sum. But degree 1, so immediately I put into 1, and 1 can be replaced with the variable t. Into 1, can you see? And degree 0 means I'll put 1 squared and made it t squared. Now what I'm going to do is I'm going to find the partial derivatives so that I can, like what you call, use the maxima minima technique. So look, I hope you still remember what's the partial derivative. When you differentiate partially with respect to x, you treat x as the only variable, or in other words, y, z, t, everyone will be treated as constants. So there we go, we get 4x, 0, 0, 0, 10 into z into 1, because the derivative of x is 1. 2 into t into 1. So we get this, 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 this. I'm sure you can manage it. Now what do you do in exam is you write like this. That will be the simplest technique. I'm just giving you the technique. I'm not going to explain the logic or anything too much. So what you have to write in the exam is, once you find all these stuff, you can write. Solving the equations, look, you can write all of them together. We get, and putting t equal to 1, because we already know the value of t is 1. Okay, so what we get is, we get 4 equations. And you can solve any of the 3 equations. Anyway, I did my homework. I got the values to be x equal to 2, y is equal to 2, z equal to 1. Now look at this, I have to tell you something very important. Your university has allowed a very powerful calculator that can be taken to the examination. So always use technology for such things. You already learned how to solve equations, etc., etc. in your class 8, 9, 10, 11, 12. That's enough. Now, we are focusing on something else. We are not like what you call interested in the classic way of solving these equations. And remember, as an engineer, your job is to bring output. You're not an artist to make things beautiful. No one expects you to go through the classic ways of method and find the values of x, y, z. So use calculators. Why I told you is I have seen many students who are in bachelor still hesitant and still who do not know how to use calculators properly. So just make a small Google search and learn how to do this stuff. Okay, anyway, solving the first three equation, I got x equal to 2, y equal to 2, z equal to 1. Now I am going to check whether this will balance the last equation. So I am going to substitute. So I am going to get 2 into 2 plus 2 into 2 plus 26 into 1 is equal to 18. I got 34 is equal to 18. That is false. So what I conclude is the given equation is not a cone. The given equation is not a cone. Okay, now let's imagine the question is instead of 9 they gave you 17. So if you want, you can rewrite the question I change the number so that actually I shouldn't have put check whether, it should have been check whether actually. Okay, so suppose the value is 17. So what happens here is you will get 17 into t squared. So automatically this will become 17 into 2, that will be 34 into t. I think you understood why I am creating the number 34 there. So automatically I will get is equal to 34. So now when I plug in, I will get 34 equal to 34. Did you get my point? Suppose the question was like 17. Instead of that minus 9, if you had 17, what happens? You will get true. And if you get true, then you will write this solution balances all the equation. This solution satisfies all the 4 equations. And it happened because the homogenized equation was a cone. And if the homogenized equation is a cone, the original equation is also a cone. And the vertex of that cone will be 2, 2, 1. Okay, I hope you understood the procedure. Anyway, after this video you can try. You can click a screenshot here. Okay, now there is one very important problem that I saw in the past year question papers. So let's do that question now. So the question goes like, prove that ax square plus by square plus cz square plus 2ux plus 2vy plus 2wz plus d equal to 0 represents a cone if u square by a plus v square by b plus w square by c is equal to d. It's a very famous problem. It comes in the bachelor's books, it comes in the bachelor main subjects like physics, core subjects, etc. Everywhere it comes. Okay, so basically they are asking you to prove that this represents a cone if this condition is set. Now what you do is you find all the partial derivatives, and you know when you do with respect to x, x will be the only variable, so we get a into 2x plus 0, 0, 0, 0 plus 2ux, and the next partial derivative will be 2by plus 2v into y Now what we do is we find the partial derivatives. So when we differentiate with respect to x, you know x is the only variable, so we get 0, 0, 0 plus 2 into u into t into 1, and the others will be 0. Similarly, the others will be b into 2y plus 2vt, and the next one will be c into 2z plus 2w t, and with respect to t, that means this will be 0, 0, 0, so we will get 2ux into 1, 2vy into 1, 2wz into 1 plus d into 2t. Now you know the method. We try to find the stationary point by equating all these derivatives to 0. So the equations are 2ax plus 2ut equal to 0, 2by plus 2vt equal to 0, 2cz plus 2wt is equal to 0, 2ux plus 2vy plus 2wz plus 2dt is equal to 0. Now when will the given equation represent a cone? If you can find a common solution, if you can find a solution which will balance all the 4 equations, then we can say that the given equation represents a cone. Now solving this is very easy, and by the way, you cannot use calculators here because these are alphabets, these are not numbers, so your calculator will be helpless. And solving is not a big deal, just take it to the other side, you get the value. X is equal to u by a, and the derivative y is equal to minus v by b, z equal to minus w by c. So solving the first 3 equations gave me this solution. Now tell me, when will it represent a cone? If this balances the last one. So I am going to write the given equation represents a cone if 2u, and what should I do instead of x? Minus u by a, plus 2v minus v by b, plus 2w minus w by c, plus 2d. By the way, t is actually 1, right? So I should have kept 1 here. I solved it in the assumption t is equal to 1. Okay, so basically you will get 2d plus v squared by b plus w squared by c is equal to d. Yeah, that's it. I saw in the question paper, very important question I saw in so many question papers. Axis and OY include an angle alpha. Prove that their line of intersection lies on the cone z square multiplied by x square plus y square plus z square equal to x square y square into tan square alpha. Okay, first of all I will show you the geometry behind it. So I will take that. So look at this, I have the 3-dimensional plane. Now can you see I have kept so many planes here, and if you look at the first plane, the x value is missing, and I'll show you something. It will pass through the x-axis. So you have to understand, any plane which passes through the x-axis will have the coefficient of x being 0. And I'll show you another thing. See, here the y value is missing, so I know it will pass through the y-axis, the green axis. See, you can check anything, you can check any of the planes. If y is missing, it is bound to pass through the y-axis. Now can you see these two planes intersect? And when we learned about planes, you learned that the intersection of these two will be, come on, tell me, what will be the intersection of these two planes? A line. Okay, now one more thing you have to understand. It is given that the angle between the planes is alpha. So remember, the angle will be always maintained alpha. And they are asking you to prove that the lines formed in the intersection will together make a cone. Look at this. Can you see another 2 planes are intersecting, another planes are intersecting. I kept so many planes, but here for example I didn't maintain the see so many planes passing through the axis OX and OY, they intersect, and now I will show you the lines created by them. Look at this, these are the lines created by those planes. I didn't do it systematically, but if you do it systematically, you can see that the lines together will make a cone. Can you see that each intersection will create a line? And if you imagine all the lines together, this looks like a mess, but still I think you can see that someone has piled up some sticks here. Okay, anyway, that's what we have to prove. So we had one wonderful observation. Any plane through OX or the x-axis will not have the coefficient of x. Now I'll tell you the mathematical reason also. Look at this. If you consider any plane through the what you call x-axis, so let's say x-axis is here, and this is the plane through x-axis, and the other axes are somewhere here, y-axis, z-axis are all there. What is the direction ratio of the x-axis? X-axis corresponds to the vector I. So the direction ratios are 1, 0, 0. Now assume that the normal to the plane is ABC. What is the normal to the plane? I am assuming ABC. Now look at this. The axis and the normal will be always perpendicular. Come on, the plane passes through the x-axis, so the normal to the plane and the axis will be perpendicular. That means the dot product will be 0. So take the dot product, you will get 1 into A plus 0 into B plus 0 into C is equal to 0, because dot product should be 0. That means A equal to 0. So always remember, any plane through the OX plane, OX axis, that means the x-axis, will have the constant term 0. So look at this. Basically, our plane will be AX plus BY plus CZ plus D equal to 0. Now the reason I did not use D here is, any plane through the origin, look at this. Now if you do not have the constant term, then the origin will balance this equation. So remember, any plane passing through the origin will not have constant term. Any plane passing through the x-axis will not have the coefficient of x. So basically, any plane through the x plane and touching the origin will be this. And if you divide throughout by b, you will get y plus c by b into z equal to 0. And for formality's sake, I am going to call it y plus n1 into z equal to 0. You saw that example, I showed you that equations, or you can rewind it and check it. So let's start the story. So I'm going to start like this. Any plane through OX will be, what is the condition? X will be missing. Constant term will be missing. So basically it will be y plus n1 into z equal to 0. You can prove in the examination if you feel like proving it. I showed you the proof. Direction ratios of x-axis 1, 0, 0. Direction ratios of the normal ABC. Dot product gives you 0. So A will be 0. So basically it ends up like this. Similarly, any plane through OY, since it passes through the origin, constant term disappears. Since it passes through the y-axis, the y coordinate disappears. So basically it will be x plus n2 into z equal to 0. Equation number 2. Now, what is given about the angle between them? Remember, this represents thousands and thousands of planes, but angle between them are what you call alpha. So let's look at this. Direction ratios of normal direction ratios of 1, 0, 1, n1. Normal direction ratios of 2, 1, 0, n2. Angle between them alpha. So here we get the relation for one line. One of the line is given by, did you understand? We are getting the generating line actually. One of the line, because angle between them is alpha, I am going to connect them. What's the formula for angle between two planes? 0 into 1 plus 1 into 0 plus n1 into n2. the whole divided by root under 0 plus 1 squared plus n1 square, root under 1 squared plus 0 squared plus n2 squared. So that's it. Basically you get cos alpha equal to n1 n2 by root under 1 plus n1 square, root under 1 plus n2 square. Now remember, now we have to generalize this because one line is connected by this relation. Now we have hundreds and hundreds and hundreds and hundreds and of lines. Together they form the cone. So what we do is we have to get rid of the quantities that we introduced, like I told in the last few videos. So what is n1? n1 is minus y by z, right? And n2 is minus x by z. So let's plug it here. So we get cos alpha equal to minus y by z multiplied by minus x by z by root under 1 plus y square by z square, root under 1 plus x square by z square. Now you can